Hello, I'm Drew Tisdelle and welcome to my thesis presentation on a hybrid digital-physical board game JavaScript library. The objective for my thesis was to develop a JavaScript library that allows for the creation of tablet-based board games. But what is a tablet-based board game? Well, a tablet-based board game is a board game that uses a tablet as the game board and uses physical game pieces to interact with the board. This offers advantages over normal board games such as sounds, dynamically changing boards, and for hidden information to be properly hidden from all players. This idea has been implemented in the past by Lenovo and Playtable. Lenovo created the Horizon 2 multi-mode table PC, which allowed for games to be played on the tablet using conductive game pieces. Playtable created its own tablet, also called the Playtable, which used RFID chip readers built into the tablet screen to detect and identify game pieces that contained RFID chips. While both inventions were innovative, they failed to become popular due to a combination of technical problems and their large price tags. Why would someone spend $400 on a tablet to play Catan when they can buy Catan for just $40? With this in mind, I decided to create a way for developers to make tablet-based board games for tablets that people already own, as there are currently over 1 billion tablet users in the world. In order to do this, I found it best to develop a JavaScript library, as this would allow the code to work with web browsers. By making the code library compatible with tablet web browsers, it eliminates the need for games to be completely rewritten to work for a multitude of different operating systems. To determine the needs of future users of the library, I first developed a paper-based prototype of a potential tablet-based board game. The game was based around the Greek myth of Theseus and the Minotaur and became known as the Minotaur's Labyrinth. It consisted of hidden information and incorporated sounds as part of the gameplay to demonstrate the advantages of tablet-based board games. This prototype was able to be rapidly developed and tested thanks to everyone in Professor DeWinter's production class who worked together to develop it in an agile-based environment for an assignment. After gaining information from the development of the Minotaur's Labyrinth, I next decided to find the technical limitations of modern tablets that I would be confined to. Through the testing and research of the most popular tablets released within the past 5 years, I was able to find that most tablets allowed up to only 10 simultaneous touch points at a single time. In addition, I found that most touchscreens were now capacitive, and thus determined the location of touch points using the interruption of the electrical currents within the touchscreen caused by a person's finger making contact with the screen. This meant that my limitations were having at most 10 simultaneous touch points and making game tokens out of conductive material so that they could be sensed by touchscreens when in contact with a person's fingers. The next problem I would need to address is how to have the library identify individual game tokens when touches can't be distinguished from each other. The solution that I found to work best was to have 3 raised dots on the bottom of a token that would touch the screen. Using these points, a triangle is formed and the angles of the triangle could be calculated using the positions at which all 3 touch points are sensed. By putting the touch points in different positions, different angles could be formed for the triangles, and thus pieces could be individually identified based on the angles of the formed triangle. Using this method, my library is able to easily identify individual game tokens without the need for specially designed tablets, such as the Playtable, that have chip readers built in and thus can be used with tablets people already own. Other than this functionality, my library focused on storing the information of tokens that have been registered so they can be identified, registering tokens, and updating the position of tokens on the screen. My aim was to give users the essential functions they needed to create a tablet-based board game without limiting how they could develop it. With the library completed, I decided to test it using a simple race to the end game I created called Roll. For this game, players would simply tap the die on the screen to roll it, and then move their token to the space marked on the screen. The game would only progress if the correct token was placed on the space. For this test game, low-fidelity tokens were made using chess pawns painted using conductive paint to allow the screen to sense the token when a person's hand is in contact with the paint on the token. For higher fidelity tokens, I found that pewter would be the best material to use as it is both cheap to produce and highly conductive. However, as low-fidelity tokens are faster to produce and make changes to, I did not produce high-fidelity tokens for testing. By having people play this test game, I was able to determine that the library was fully functional as the game could not be completed if the library functions were not working correctly. The testing consisted of having players go through the entire game while I noted how they moved the token, noted if any issues occurred, and had the player take a survey after the sessions to see if they noticed any issues. The only issues that arose were from the paint rubbing off on the low fidelity tokens and thus making it hard for them to be detected if too much paint was rubbed off. This issue can easily be avoided by using pewter tokens as there is no paint to be rubbed off. With testing complete and the library determined to be fully functional, I thoroughly documented the code and named the library the Minotaur's JavaScript library after the prototype game. The library is now publicly available on GitHub for people to access, and I plan to continue updating and testing the library so it remains compatible with tablets for years to come. I learned a great deal while working on this project and hope to not only be able to create a tablet-based board game version of the Minotaur's Labyrinth using the library, but hope that others will be able to use this library to create their own games as well. Thank you for your time.